This is a 3D animation video to help the understanding of the operating procedure for the steel-making facility in Indonesia. Please take note that this video may be slightly different from the actual facility inside. The dump truck carrying flux and ferroalloy enters the ground level hopper and stores the material in the corresponding ground level hopper according to time. The amount of material is set by the vibrating feeder, fed to the number 1 belt conveyor and conveyed to the number 2 and number 3 and number 4 belt conveyor, which are on the high level stage. The material which arrived at the number 4 belt conveyor is stored in the specified high-level storage hopper using the tripper car. The high-level storage hopper has a sensor to measure the amount of storage. If the storage amount reaches the amount set in the belt scale in the number 2 belt conveyor, the material transportation will stop. For special ferroalloy, a one-touch bag or can is loaded onto the freight elevator using the forklift and stored in the specified storage hopper. For the scrap chute, it is transported to the weighing system using terminal tractor, and then the scrap amount is displayed. The scrap amount is fine-tuned using the scrap loader. The completed scrap chute containing scrap is transported to the charging bay for charging using the terminal tractor. After the transportation, the scrap chute will be lifted by the hot metal handling crane and transported to the converter charging position for scrap charging. Here, the charging side door of the clean house will be opened. The converter will be tilted 40 degrees towards the charging side to level with the scrap chute and stopped. The hot metal handling crane moved towards the converter and the scrap chute is inserted into the converter. By signal, the auxiliary hook holding the back of the scrap chute is hoisted. At the same time, the converter tilting speed is adjusted to charge the scrap into the converter. After scrap charging is completed, the auxiliary hook is lowered and the scrap chute is withdrawn slowly from the inside of the converter. After the withdrawal of the scrap chute is checked, the converter is tilted to the tapping side at 30 degrees, and after one cycle of tilting to the charging side, the converter standby at approximately 45 degrees towards the charging side for the hot metal charging. After scrap charging, hot metal is charged into the converter, which is in standby position. When the hot metal charging ladle is completely away from the converter stands upright and the clean house door will be closed. To suppress the dust within the charging ladle, the hot metal charging ladle is tilted and moved to the mist spray installed at the left door. Water and compressed air will be sprayed to the ladle through the nozzles. The ladle, after completed spraying, will be settled down on the pallet and transported to the furnace using ET car. The flux material for blowing process is stored in the high-level storage hopper during the charging of scrap and hot metal. The amount of flux needed for blowing is set and weighted and is discharged by the magnetic type of vibrating feeder and stored in the weighing hopper. There are 2 sets of main lance installed at both sides of the converter. The lance for oxygen blowing is moved to the operating position by hydraulic cylinder. By pressing the blowing start button, nitrogen for sealing will be sprayed through the nozzles in the flux chute, lance dome, and sublance dome. When the lance reaches the designated position from the hot metal bath level through the main lance dome, the hot metal will be fired. The amount of oxygen and bottom bubbling gas will be set at a predetermined value. The weighted flux material will be injected after ignition. When the hot metal reacts with oxygen, silica will react first, and the molten metal temperature will increase. Carbon will be released in the gas form, and mangan and phosphorus will react with the flux, and the impurities become slag. Skirt is at 1000 millimeters over the converter mouth before blowing, and descends by 100 millimeters during the early blowing process. When slopping or spitting occurs during blowing, skirt will be opened and closed repeatedly during operation. ID fan will also operate corresponding to the change in skirt position. The cooling stack over the hood, located at the top of the skirt, received a lot of radiation heat and consists of membrane tube for cooling. The off-gas temperature at the converter mouth during blowing is approximately 1,500 degrees Celsius, which is cooled down after passing through the hood and cooling stack. Radiation heat exerted on the cooling stack will generate steam through the boiler system. The generated steam is stored in the steam drum and steam accumulator, which is installed outside. The dust contained in the off-gas will be collected when passing through the deflection bend, and the off-gas passed through the gas conditioning tower for additional cooling. During early blowing, the nozzles sprayed steam vertically. After that, it sprayed water to collect the coarse dust. The collected dust is discharged through the chain conveyor, and second dust collection is performed by the electrostatic precipitator. The impurities inside the hot metal are removed during blowing, but to accurately predict the target temperature and the endpoint oxygen according to the steel grade, the ingredient is measured using sublance at 80% of blowing. Sublance measurement work is implemented by 4 types of probes in the storage rack of the sublance. If the probe intended to be used during blowing is selected, the probe lifter began to operate and moved the selected probe to the probe erection frame. After the probe stands upright, the loading device of the manipulator rotated the probe and moved it to the sublance position. Then it is ascended by 800 millimeters and the probe is mounted on the sublance. After the probe is mounted, the grab is opened and the loading device moved to the original position, and the preparation of sublance measurement is completed. The used probe is detached after measurement. The unloading device of the manipulator moved forward to disassemble the probe and rotated it. The waste probe is dropped to 12.5 meter position through the drop chute for disposal. After measurement from the sublance, either the target value is corrected or correction work is implemented to match the target value. If it reached the target oxygen value, blowing work is completed. After blowing is completed, main lance is ascended to the standby position and the oxygen valve is closed. At the same time, the skull removing device located at the lance dome removed the skulls attached to the lance. The probe installed at the tip of the sublance is used to check the end component and temperature of the molten steel and checked whether it reached the target temperature and oxygen. If it reached the target value, it will proceed with tapping. If it doesn't, blowing is repeated until the target value is achieved and the blowing process stopped. During blowing, ferroalloy and deoxidizer is fed from the storage hopper through the feeder and discharged to the relay hopper. The special ferroalloy is also weighted and discharged into the relay hopper, same with the ferroalloy. During blowing, the teaming ladle transfer cars stand by at the tapping position. The swivel chute at the standby position rotated to the ladle direction to inject the ferroalloy, and tapping will start according to the tapping signal. The converter is tilted until 75 degrees at high speed and checked whether steel came out from the tapping hole. From 75 degrees to 98 to 100 degrees, the converter is tilted slowly while checking whether the slag overspilled through the converter mouth. The teeming ladle transfer car also moved slowly according to the tilting angle of the converter. When 1/3 of the teeming ladle is filled with the steel, the feeder of the relay hopper is operated and ferroalloy is injected to adjust the composition of the steel and also for deoxidation process. Dart is selected at the dart storage and mounted to the arm before tapping. When 4/5 of ladle is filled with steel after tapping, dart will be injected into the converter vessel. After all of the steel is tapped, due to the difference in specific gravity of the steel and slag, the dart will stop the slag from flowing out through the tapping hole. The slag stopper installed at the trunnion ring at the tapping side began to operate when the tapping is completed, and N2 is sprayed from the nozzles into the tapping mouth to cut the slag. Then the converter is tilted back to 30 degrees towards the charging side and standby. The teeming ladle transfer car is moved to the ladle bubbling area. In the ladle bubbling area, the lance for temperature measurement is mounted with probe for temperature and sampling and is operated manually. Lance is descended to sample the molten steel and ascended after checking the temperature. The probe is detached manually, and the sample is taken out and cooled down with cooling water. The sample is placed into the sending device and sent to the analysis room. After that, the bottom gas installed at the bottom of teeming ladle is used to perform bubbling for a constant period of time to equalize the temperature and homogenization of the ferroalloy inside the teeming ladle. Then the teeming ladle transfer car is moved to the secondary refining bay. Slag pot transfer car moved to the converter area for removing the remaining slag inside the converter. After the slag pot transfer car position is confirmed, the converter is tilted to 130 degrees, while having the slag being poured into the slag pot transfer car. When the slag is expected to overspill the slag pot, slag stabilizer is injected, or the slag foaming stabilizer is operated to stabilize the slag. When the slag is removed completely, the converter is tilted back to 40 degrees for scrap charging. When the slag pot transfer car stopped at the slag pot transportation position, the slag pot is moved by the big loader and the converter process is completed.